So I need to shade where it's true. This point is true, so I'm going to shade outside. Okay? Any questions about that? Now that would be all fine and good if that's everything that was quadratic inequalities, right? But think about what we did yesterday. What did we do yesterday? Systems, right? And you know we have to take that into account as well. We can't just do systems of quadratic equations. We also need to do systems of quadratic inequalities. Okay? Now you know that if two problems show up, or two inequalities show up on one problem, that means I'm graphing them both on the same graph, right? I have to do them separately, but they're going to be both on the same graph. Does that make sense? Yes. Okay. So let's graph the first one. Okay. If it's all right with you, I'm going to graph it in orange to make it stand out a little bit. Okay. What form is this in? We could say it's in standard form, but wouldn't it be easier if we said it was in vertex form? It just doesn't move left and right at all, does it? So my vertex here is where? Just up 4. Okay? Oh no, what did I do? Can you tell me? It does. It goes down 4. I didn't pay attention to my signs, you know, my nemesis. Okay? 1, 2, 3, 4. So please forgive me for that. It is down 4. It's not, no, not up 4. Just down 4. Down 4. Okay? Now, is this parent function shape? Is there a multiplier? No multiplier, so it's parent function shape. So from the vertex, I can go over 1 up 1, over 2 up 4, and over 3 up. Good job. And I know my parabola is symmetric. So I know my parabola looks like that. I even think in this parabola I can go over 4. If I go over 4, how far do I go up? What's 4 squared? Oh, 16. Okay. 1, 2, 3, 4. Now, was I required to get that last point right there? No, I wasn't even required at anything past here, right? But now, isn't it really super easy to see my parabola? Okay. Now, before I can go any further, what kind of a line am I drawing? Dotted. Dotted. Now, what's left to decide? Shading, inside or outside, right? Except this time, are we actually going to shade? No, we're going to decide where we will shade when it's time, right? Okay, if I choose 0, 0, 0 is greater than 0 minus 4. 0 is greater than negative 4. That's true, right? If it's true, I shade toward where that point is. So in this case, I am shading inside. Okay? Again, I'm not going to shade yet because I only want to shade one time, right? You ready to go on to the second equation? Or second inequality, excuse me? Okay, I'm going to graph it in green, so it's quite different. What form is this? Again, we could say it's standard form, but vertex form makes it a little easier, okay? So, how far left and right did I go? 0. And how far up or down did I go? 5. And this time, actually, I went up 5, right? 1, 2, 3, 4, 5. Now, which way does this open? It does open down because it's a negative multiplier, right? But this time we have a multiplier. So here's what I need you to remember, okay? I can't go over 1, down 1 because that's parent function shape and this has a multiplier. But this is an easy multiplier. It's just a half. So instead of going over 1, down a half, and I'm going down because it opens down, right? Instead of going over 1, down 1, I'm going to go over 1 and down half of what I would have gone. So half of 1 is a half. And since I know it's symmetric, is it okay if I go ahead and draw both points as I go? Instead of going over 2 and down 4, I'm going to go over 2 and down half of what I would have gone. So I'm only going down 2. Instead of going over 3 and down 9, I'm going to go over 3 and down half of 9. 1, 2, 3, 4 and a half. Does everybody understand where I'm getting the shape of this parabola? So instead of going over 4 and down 16, I'm going to go over 4 and down half of 16. Yes, absolutely, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I probably could put some more points to help me see it a little bit better, but is that okay for you now? Before I draw it, I have to look. What kind of a line am I drawing? Solid. And now I have to figure out where to shade. If I choose 0, 0, I get 0 is greater than or equal to negative 1/2 times 0 squared plus 5. 0 squared is 0 times negative 1/2 is still 0. So 0 is greater than or equal to 5. 0 is greater than or equal to 5. Not true. So wherever the point is, I don't shade there. So where do I shade? Outside. So where am I actually, now that I have both of them drawn, where am I actually going to shade?
Above the green, right up there.
Above the green, but inside the orange, right? So here. Does that make sense? Yes or no? Okay. Any questions about it? You got it? Okay. X squared minus 3x is less than or equal to 10. X squared minus 3x is less than or equal to 10. How is this problem at the very basic level different from what I just did?
It's flipped around.
Is it? Yeah, there's no y in here, is there? How many variables are there?
1.
Only one. I had 2 variables here, so when I graphed it, I had to graph it on an x and a y axis, right? How many axes are here? 1, just an x-axis. So I'm going to graph this on a number line. Still graphing has to occur, right? But it's going to be on a number line. Okay? Now, I don't want you to panic because you already know how to do this. We've done quadratics and then we've done linear inequalities. What I have to just show you today is how those two things fit together. Okay? So what do you think you should do first on this problem? Yes, we want to subtract 10 from both sides, right? Now, somebody said make it equal to 0, and I know what you meant. Do you realize why I had to correct you a little bit? Okay, that's okay though. X squared minus 3x minus 10 is less than or equal to 0. What do you think we should do now? If this side is 0, what do I do with this side? Which one of these do I want to use? Factoring would probably be the easiest at this point, right? What two numbers multiply to be negative 10 and add to be negative 3? Negative 5, positive 2. Has anything we've done so far differed from when this was an equal sign? No, it has not. Okay? We're still doing what we think we should do, even though I haven't told you what to do. You're guessing, and you are guessing correctly. Okay? So I need to take each one of these factors and set it equal to 0. I know that seems a little weird because this is an inequality, but just go with me for a second. Okay? If I add 5 to both sides and I subtract 2 from both sides of that one, I get x equals 5 and x equals negative 2. Now this is the point when this was an equation that we were done, right? Since it's an inequality, we have a couple more things to do, okay? First of all, we have to write our answer, and part of our answer is the graph. Just like it was over here, the graph was pretty much our whole answer, right? It's part of our answer here. These two things, these two endpoints, these two numbers are the important numbers on the graph. I want to have 3 numbers on my graph though. What else do I want on my graph besides these two numbers? 0. So here's -2, here's 0, and here's 5. Does it matter where I put those numbers? Oh yes, right? I want them in order. Okay, least to greatest, I want them in order. Okay, now I have to figure out where to shade on this number line. So I have to figure out what's true. But here's the thing about this, okay? Just like we shaded inside or outside here, we're going to shade inside or outside here. Inside of the two numbers or outside of the two numbers. Guess what number we choose to decide? 0. That's why we put it on the number line. Okay? Take the 0 and plug it back into the original inequality. 0 squared minus 3 times 0 is less than or equal to 10. So 0 is less than or equal to 10. Is this true or not true? This is true. So guess where I'm going to shade? Where the 0 is, right? So I'm going to shade in between. So I'm shading inside the two numbers, right? Now, did you notice I didn't get close to the -2 and the 5? Those are my endpoints, and something has to go there based on my inequality sign. Do you remember what has to go there? One of two possibilities. Either an open circle or a closed circle, depending on what the sign is. This sign is less than or equal, so which one is that going to be? So less than or equal or greater than or equal is going to be a closed circle. What's going to make it be an open circle? Just than, less than, or just a greater than, right? So on these, closed circles, and then I can shade all the way between. Now I have one more thing to do, and I have to actually write the answer. This is part of my answer. Now I have to have this written in a math sentence, okay? Because I shaded in between the 2 points, this is called an AND statement, and I can write one inequality to take care of all of my answers. I write -2 is less than or equal to x is less than or equal to 5. Do you see how that's one sentence? One inequality? Well, it's got two inequality signs, but it's one complete sentence because x value is allowed to lie between -2 and +5. Any questions on that one? So is it okay if I show you one more? Okay. If it's not okay, I'm going to do it anyways. Okay. So x squared minus 5x minus 7 is greater than 0. So I've already got 0 on one side, right? So what do I need to do here? Decide how to solve it. You want to factor? Okay, what two numbers multiply to be -7 and add to be -5? Oh, dang it. We need to do quadratic formula this time, right? Okay, so A, B, C. X equals -b plus or minus the square root b squared minus 4ac all over 2a. B squared minus 4ac, remember? Okay? So x equals 5 plus or minus the square root of, 4 times 1 times -7 is -28, which leaves 25 minus -28, so 53. But just as a reminder, if that's not something, if that is something you struggle with, please don't let it get the wrong answer on the problem because it's something you struggle with. Okay? Did I say 53 and then write down 52? Sorry. It should be 53. Okay. Here's another way I know that, because if I say 25 minus 4 times 1 times negative 7, I get 53. Okay. If you feel comfortable doing it with your calculator, with your brain, use your brain. If you need to check with your calculator, you can. Okay. All over 2, right? Now here's the deal. When we were doing these, when this was an equal sign, what did we do when we got here? We stopped, right? That's what it was equal to. Okay? If I have to graph this on a number line like this, is this a number on a number line?